Hello everyone. Today I start my third GAMSAT preparation course. Today I will teach you how to write ions and Ionic equation. And briefly, before we start new concept, let's see what we study at Wednesday. We study electrolyte, acid-base and salt reactions, and electrolyte is substance which in solution can conduct electricity, and if substance conduct electricity, it's electrolyte. If substance not conduct electricity, it's not electrolyte. And electrolyte we can group in by two big groups, weak and strong. And if we discuss more deeply what typically strong electrolyte, it's acid, bases, and salt. And weak electrolyte, it's also acids, bases, and salt. So if compounds acids, base or salt, it can be how strong electrolyte, it can be or weak electrolyte. Anyway, and we discuss 5 cases when reaction happen. It's when, for example, strong any acid react with base. It's when acid react with active metal. When active metal react with salt of non-active metal, strong acid react with salt of weak acid, strong base react with salt of weak base. It's when two soluble salt react, it can form insoluble salt. So whole possible reaction we can group into these 5 groups. So if you're dealing with acid, base or salt, reaction possible. If acid react with base, it's always. If acid reacts with active metal, always. Salt react with active metal, always. Strong acid or strong base react with salt, yes, it's also always. And if from 2 soluble salt you can get at least 1 insoluble salt, a reaction will happen. And today we will talk more deeply what it means electrolyte and how we can write equation and property. At first, electrolyte, its meaning conduct electricity. Electricity, it's typically, if for example wires, inside wires we have small electrons which directly moving into some direction. So electric current typically it's in wires, it's a directed flow of electron, but it can be any direct flow of any charged particles. Smallest one, fastest one, it's electron. But in chemistry we're also dealing with charged particles. For example, we have cations and we have anions. For example, cations such as H+, K+, what else? K, 2+, and anions OH-, Cl-, NO3-. And if particles charged positively, we name it cations. If charged particles charge negatively, we name it anions. And if we put in solutions to electrode, one of charge positively, one of charge negatively, electrode which attract cations name cathode, electrode which attract anions name anode. So positively charged cations moving to negatively charged cathode. So cations positive charged, anode cations positively charged particles, cathode negatively charged electrode. Anions, it's negatively charged particles, anode, it's positively charged electron. And any electrolyte or acid or bases or salt can be dissociate, and we have three groups of compounds: acid, salt, and base. For example, HCl completely irreversible split into H plus and Cl minus. For example, hydrochloric acid, it's strong acid. It's completely dissociate, it's strong. Most, even all strong acid in solutions dissociate completely. Or phosphoric acid, it's weak acid. It's reversibly dissociate. Produce H plus plus H2SO4. It's weak. And both these acids right now in my stomach, one of them, hydrochloric acid, present in any stomach, and another acid, phosphoric. Oh, error, sorry. Phosphoric acid is from cola. If you drink cola, Coca-Cola, Pepsi-Cola, Kibla-Cola, any cola, it's typically acidic, and acidic tastes come from phosphoric acid. It's weak acid. Base. Most popular in lab base, it's NaOH, because it's cheapest strong base. Every cheapest reagent typically most popular in world. And this base split into Na plus plus OH minus and splitting completely 100%. And if we deal in, for example, with iron hydroxide, it's weak base, very weak base, main component of rust. And this base produce OH minus, but not many. And salt, soluble salt. Salt number one, kitchen salt. It's so popular salt, so some words get from this salt. Literally, for example, words solder, its meaning, it's from ancient Rome's mean someone who get salt for serving. So at first name soldiers get people who serve and get salary in piece of salts. And this completely dissociate into Na plus and Cl minus. And one of weak not dissociate salt, it's potassium, calcium carbonate. It's partially by a small percentage dissociate into Ca2 plus and CO3 minus. So if we generalize, acids produce H plus, bases produce OH minus, and oops, and salt, what we name one moment, and salt each particles which conduct electricity and split into fragments, and just say it. So if we group in salts, it's consists of any cations, any anions except H plus and OH minus. If compounds contain OH minus, which can be removed, it's base. If particles can remove H plus, it's acid. So if you have compounds, you must recognize what you're dealing with: acid, base, and salt. Easiest way, it's name. If something named phosphoric acid, it's probably acid. Or acetic acid, it's also acid. Another way how we can recognize acid and base, it's contain H and non-metal only. For example, HCl, HNO3. If compounds consist of only non-metals and contain hydrogen, more probable it's acid. With organic, it's also by name or present COOH group, if you have any information about structure, or shown something like H, C, X, Y, O, Z. So if it's in substance present separately shown this group COOH, it's meaning only one, it's acidic groups. It's information about structure. So if you have empirical formula, no way to find it's acid, base, or salt if you deal with organic. But if you have structural formula, it must present COOH, or even it's almost like empirical formula, but you have separately write two hydrogen and one of them at first. It's mean in formula someone show for you information you're dealing with acids, especially. So without any information about structure, you can't say. It's clear? Someone can comment? I never see comment before, but please, someone. Okay, if anyone can, so continue. So important acid, hydrochloric acid inside me, nitric acid, it's for nutrition, very often used. Phosphoric acids in drinks, hydrochloric, perchloric acid, very often you can see it's in salt. How determine you dealing with strong acid or weak acid? At first, you can memorize most acid are weak. So if you're dealing with H2SO4, HCl, HBr, it means you're dealing with strong acid. Sometimes you can get some information by additional data. If acids know Ka or pKa negative and Ka very big, it means you're dealing with strong acid. So all acid except this, it's strong or by additional data. So for example, if we have HNO3, it's strong acid because it's from list. Or H2SO3, it's not from list. So if it's not from list, it means it's weak acid. Or HCOOH, it's acid but it's not from list, and most acid it's weak. So if you're dealing with weak acid, HCOOH, like strong acid, it's produce H plus, and what left will be with negative charge, HCOO minus, but it's reversible. Or another example, HF, it's also weak. It's also weak acid because it's not from list, and it's particularly H plus F minus, and H2CO3, it's H plus HCO3 minus, and second step, HCO3 minus also split into H plus H plus CO3 to minus. In all cases, when we're dealing with dissociation, we split substances into couples, cations and anions. And number of cations and anions, charge of cations and anions before reaction and after reaction are always same. And HCl, it's completely split into H plus Cl minus. Another group of compounds, it's base. It's typically present in name words hydroxide, if you're dealing with mineral, and if you're dealing with organic, it's present fragments where present nitrogen which bonded with hydrogen or carbon. And most compound with nitrogen, it's bases, but it's very hard to determine by empirical formula, but if present nitrogen, it's very probable you're dealing with bases. For bases, we dealing with same principle as for acids, how to determine strength of base. Just memorize, most bases are weak, so if base is from this list, it means they're strong. NaOH, KOH, rubidium OH, some elements first and second grouped except top one. And if you know idea about, if you forget it, sometimes you can find additional data. If no data in table with Ka, pKa or big pKb or negative pKb, it means it's strong base. but easiest way, I think it's memorized. Its most important bases, NaOH, it's cheapest strong base. KOH also very often used in pharmacy. Methylamine contained in fish and smell of fish. It's came from amines. Ammonia, probably everyone known. So bases dissociate as acids. Strong bases dissociate completely into OH minus, and what left? For example, zinc hydroxide, it's also base, but very weak. It's also produce OH minus and zinc OH plus. And if you know formula of compounds, and if you know these compounds produce OH minus, it means you must write OH minus, and just count. You have 2 hydrogen in left side, you have 2 hydrogen in right side, you have 0 charge in left side, you have +1 and -1 in right side. A more complicated situation for dissociation with weak organic bases. For example, if we're dealing with ammonia, it's also produce OH minus, but in this reaction we dealing with NH with water, and we forming NH4 plus, and we can easy to find what we're dealing with. And with salt also can be soluble, insoluble, strong electrolyte, weak electrolyte. It consists of remains of metal, with organics, it's something like amine, sometimes something else with base. It's much more complicated, so it's more hard to do it. And with salt we also can recognize its strong electrolyte or weak electrolyte. If salt contain groups K plus K, sodium, NO3, HCOO minus, K and Na plus, it's cations, NO3 and CHCOO, it's anions. All salt with these cations and with these anions always soluble. Almost all salts except almost all salt silver except halogenate, it's always insoluble. And one of most important insoluble salt, it's calcium sulfates and calcium carbonates. Another way for find its strong electrolyte or weak electrolyte, it's Ks. We discuss it in next week. If in table you see Ks, constant of solubility, or pKs, power of constant of solubility, it's salt insoluble. And most important salt, NaCl, kitchen salt, potassium dichromate. It's a very popular oxidizing agent in organic chemistry. calcium carbonates and calcium sulfate, building material. Salt dissociate into cations and anions. Strong electrolyte, soluble salt. Irreversible split into Na plus and Cl minus. Weak electrolyte like AgCl. And reversible dissociate into Ag plus and Cl minus, or calcium carbonate. Mostly it's not soluble in water, but can be splitted into part by Ca2 plus and CO3 minus. And let's trick and train how we can recognize what we dealing with. HNO2. It can be strong acid, weak acid, strong base, weak base, soluble salt, and soluble salt, none of them. If someone knows what is this compound, I will be pleased if you message me in YouTube chat. It contains hydrogen, only non-metal. Do you have anyone idea? No? Okay, it's weak acids because it's contain only non-metal and contain hydrogen, H2SO4. It's strong base, it's from list. Aluminum oxide, none of them. It's not acid, not base, not salt. And let's write how we're dealing with this electrolyte reaction. For example, acid with base forming salt and water. HCl with NaOH is forming salt and water. It's strong acid, so we write it H plus Cl minus. It's strong base. It's also meaning it's completely dissociate and forming ions. And if we simplify, in left and right side we have Na plus, and left and right side we have Cl minus, and we get net ionic equation H plus plus OH minus forming H2O. It's how write ionic and net ionic equation for reaction acid with salt. Another case, zinc with HCl. It's formed salt plus hydrogen. Zinc, it's not acid, not base, not salt, plus 2H plus, because HCl it's strong acid, it's completely dissociate, and form zinc 2 plus plus 2Cl minus and hydrogen. So we split into ions only strong electrolyte, and strong electrolyte it's strong acid, strong base, and soluble salts. And if we simplify and cross everything what equal in left and right side, we get net ionic equation for this reaction. Another case, salt plus active metal. Copper plus silver nitrate, and copper nitrate and to silver and balancing strong acid, strong base, and soluble salt dissociate into ions, so we get 2Ag plus NO3 minus. So any strong electrolyte in ionic equation we completely split into ions. Any weak electrolyte we left in form of molecular. Simplify and we get net ionic equation. In net ionic equation we see it's only two-part. Copper react with cations of silver and form cations of copper and atoms of silver. As you can see, in all these cases we get net ionic equation if reaction involve with electrolyte. It's must present net ionic equation. For example, Na2CO3, it's soda. It's actually why sodium name sodium, because it's come from soda. Weak acid H2CO3 dissociate. In ionic form, any salt we split into cations in anions. Any strong acid we split into cations in anions. So for net ionic equation and ionic equation, we need to split all strong electrolyte to part, strong electrolyte only. Net ionic equation we get if we simplify and cross everything from ionic equation. If something in left and right part same, we remove it. And how we get with weak base, for example, zinc chloride plus KOH. Zinc hydroxide, it's very, very weak base. In ionic form, we split strong acid, strong base, and soluble salt. Zinc chloride is soluble salt. Weak bases not dissociate. Weak acid not dissociate. And if we cross, simplify, zinc 2 plus OH minus, zinc hydroxide. If you can write net ionic equation, if you're dealing with electrolyte, reaction will happen. It's no excuse. So if you can write net ionic equation, it means your reaction not happen. For example, in this case we can write AgCl plus Na. For this reaction we dealing with one soluble salt, another soluble salt, we get insoluble salt, and cations and anions, and if we simplify we get Ag plus one moment, oh, not all, Cl minus AgCl. If we have for example NaF plus KCl, both soluble salt actually, I just know it, NaCl plus Kf. Even if we write reactions in ionic form, we can find all ions, all salts split into cations and anions completely, and you can't write net ionic equation. If you can write net ionic equation, it means no reaction at all. So all electrolyte react if we can get net ionic equation. No excuse. Salt, acid plus base, net ionic equation, like this. Acid plus metal, net ionic equation. Salt plus metal, we get net ionic equation. Can get strong with salt of something weak, same. Salt with salt, we can get net ionic equation. So in any case, in any situation, we can get net ionic equation for reaction which happen. So if we generalize all possible reaction of electrolyte, it's when we can write net ionic equation. And we can write net ionic equation for case if we from strong get weak, or from strong get non-electrolyte. So strongest decrease, activity decrease. If something, if activity decrease, is strongest decrease, reaction will happen. So it's all introduction for this week. Thanks for watching. You can support me and help me make this video better and better. You can subscribe. A lot of who watching subscribe. Thanks. I in description message my Facebook account group, so add it, and I will announce programs, material, free stuff in groups. You must visit my online lesson regularly. It's not long. Sorry for previous delays. You can send me questions on YouTube, email, or Facebook. You can one question or many questions. I are oriented by your feedbacks. If someone say I not understand these questions, and all of you send me, please help me with this. It's probable I will make this because it's actually for students video and not for me. So if someone very often ask me something, it means I need to do this in webinar. From yesterday I will start to make online quizzes. So best option, I think, if you will spend each day in evening about half hour for watching my video, for solving problem. If you will make it regularly, it's more easy. So better if you each day spend 1 hour, 2 hours, then whole day, and then nothing. And you can invite friends, because if more watcher, better content. And the next week, all next week, I will discuss why people do something and why reaction do something. In both cases, we're dealing with same laws and we're dealing with same principle. Reaction happen, and reasonable people make a decision by same calculated reason. And by understanding this, we can discuss acidity, pH, and indicators. It's very popular. It's most often question about